Welcome back. Enhancing LLM. All right, so as you look at what we've built so far and we climbed this tech stack, we arrived at LLM integration. In the last lecture, I talked about how you can build products that are integrated with LLM, and I offered two ways you can make LLM return or respond with what you have in mind. One was prompt engineering, and the second was fine tuning. And these two are fundamentally different. Fine tuning was about updating the model, impacting the model in some ways. And prompt engineering was about leaving the model as is, but focusing on the prompt itself. I want to talk about two techniques today to further enhance LLM. And these two both impact the prompt. So in some ways, it's similar to prompt engineering. There is no impact to the LLM. All right. So these two techniques are tools or function calling and RAG, which stands for Retrieval Augmented Generation. We're going to talk about tools first. Regardless of how intelligent a person is, there is a limit to what they can accomplish if they don't have access to any tools. Think about this office worker. She may be very intelligent, but she would not be able to deliver much if she didn't have that notepad, the pen, the computer, the phone, calculator, so on and so forth. The same holds true for LLM. No matter how intelligent it is, there is a limit to what you can get out of it if it doesn't have access to tools. Let me demonstrate what I just described, the limit to what LLMs can do if they don't have access to tools. All right, here you see the familiar code of establishing the connection with OpenAI and sending a message. And the message is, what is the weather in Tokyo? And I'm using GPT-4o, which is one of the most recent models by ChatGPT. But the response says, I'm unable to provide real-time weather updates, and I'm not surprised by that. But I just want to highlight that without tools, these language models can't really deliver a whole lot. I could have similarly said, what is like the multiplication of two large numbers, and it would give me an incorrect answer. Now, both of these would have been solved if the LLM had access to tools, calculator for arithmetics, and maybe some weather API for the weather. And as a matter of fact, today I'm going to focus on that weather API tool integration with LLM. When you have the tools accessible to the LLM by the end of this lecture, what you're going to find is something like this. When you make the call, like I said, to the same GPT model, you're not going to touch the model itself. What you're going to get is, in this case, I asked for weather in New York, doesn't matter, but it actually gives you the correct answer. And that's because the LLM has access to tools. All right? So this is what we're going to talk about. So how does it work? What did I do in order to be able to get the actual weather data from my request as opposed to the generic response that it doesn't know? So here's the walkthrough of it before I show you the code. The user says, what's the weather in Tokyo? It doesn't go straight to the LLM. It goes to this piece of script, the Python code that I just gave you a glimpse of. And what it does is that it put that message into a larger prompt and send the prompt to the LLM. And let me show you what that prompt essentially says. The prompt has a system message and a user message. The system message says, respond to the user. If you need weather information, just respond by saying curly bracket, tool, weather, city, the name of the city. And now this is what the user said. He said, what's the weather in Tokyo? But because of the context I provided to this LLM in my prompt, it knows that it should respond, as you see in the orange text, with tool, weather, city, Tokyo. Again, I didn't hard code anything into the LLM. The LLM has enough intelligence to figure out whether it needs the tool that I have made available to it. And it doesn't actually call the tool or do anything. It just responds with the format that I indicated in my prompt. But now my software gets this response, look at it, says, oh, there is a a JSON with tool, weather, and some arguments, I need to call the weather API. And this is something that you hard code into your script. Now the software, the script, gets this response. And when you look at the response, there's an if condition in that where it says, well, if there's a tool calling, let's call that function. The function is called weather, and the argument to it is Tokyo. So it calls the weather API, which is a third-party API, get the response, which is 27 degrees, and then send the response back to the user. This is the recipe for tool calling or function calling. The LLM itself doesn't actually call a function and do anything. The LLM sees a prompt and predict the next tokens and respond to that prompt. But the software that sits between the user and the LLM is responsible for parsing that response from the LLM and making calls to the functions if necessary. Now, what if the user is not asking about the weather? So here's what's going to happen. Let's say the user asks, what is 2 plus 2? Again, the system prompt remains the same. Now the user message is updated, what's 2 plus 2? LLM is intelligent enough to understand, to answer this question, it doesn't need to use the weather API. So it just responds, says it is 4, and then it comes back as it is 4. Now let's go back to the code and see how we can implement this. All right, so this is where we started, right? This is the vanilla code for calling OpenAI language models. There is no system message. I just included a user message, and sure enough, I got a response that is not useful. Now, the first thing I need to do in my script is to define a function that I call getWeather, and the argument to it is city name. And what I do here is I'm just calling a third-party weather API, and the argument I provide to it is the name of the city. So I'm sending an HTTP request, get the weather of the city, and then return the value. And if I run this function, say get weather for Tokyo, this is the response I get. It has all the weather information about Tokyo, the wind and the humidity and all that, right? This function has nothing to do with LLM. It's just a function that you can call if you want to send a request to a third-party vendor. But now that I have that function, I can update my prompt that I send to OpenAI. And this is how I'm going to do it. The user message remains the same as before. What has been updated here in the prompt is that I've included a system message or a developer message. System and developer are interchangeable here. And what I'm saying here, the context I'm providing to the LLM is that you're an assistant who answers questions. You have the following tools available. If you need to use any of these tools, your response should include the name of the tool and the input arguments to the tool. So here I'm giving it instructions what to do in case it needs to use any of the tools. And the tools that are available is get weather, and that's the only one actually. I don't have any other tools. So example, if the user says what's the weather in Paris, what it needs to return is a response in this format. And this is what I came up with. This is not like a standard or anything. I said, well, return a JSON. The final answer field should be empty, and then the tool calls field should have this, right? The second example, if somebody asks a question that is not weather related, let's say what's 2 plus 2, then the response should have the same schema as before, but the final answer should be populated because you already have the final answer. You don't need to call any tools. And sure enough, the tool call should be an empty field. So I run this, and when I get the result, now within my script, I go parse the response. If there's a final answer in the response, like this is not empty, but it's more like this, then just print that. That is the final response the user needs. But if there's a tool call and that tool is getWeather, then I want to go and call the getWeather function that I had defined previously and provided the arguments that the LLM provided to me, and that is the city name, and then print the weather. And if I do that, this is what I get. Now, just to be clear, what you see here is not the response provided by LLM, but rather by the function, by the getWeather function. What came out of the LLM is this RES or result, which I can run it here, and this is what came out of it. It says the final answer is empty, which means the LLM decided it doesn't have the final answer, but the LLM decided that it needs to call the getWeather function, and the argument it should provide to it is Tokyo. So what I showed you here was writing the code from scratch to really give you the intuition behind what's going on in function calling or tool calling. But OpenAI and LangChain and other libraries have provided easier means of using these tools. So you don't have to write all these conditions and figuring out the best way to come up with the system prompt. And I'm going to show you how you can do it in OpenAI using their tool calling capabilities, right? So behind the scenes, the same thing is happening, but it's going to be a little easier for the end user because OpenAI has created some APIs for you, made it easier for you. So this is how you would do it if you were to use the current API or the capabilities of OpenAI. What you do is that you create a list of tools, and I have only one tool, which is getWeather. There's a description for it, there's parameters, and the field that is required to a city. And then when I send a request to OpenAI, I don't need to write that system message that says you have these tools available and then provide a description of it, but rather I say here are the tools that are available to you. And the tool choice is auto, which means you get to decide if you need to call a tool or not. There might be some other applications where you want to ensure that the LLM calls the function, but not in our case. And the response from LLM, I'm gonna scroll. You see there's a tool call, and that tool call is for getWeather, and the argument is Tokyo. And now that I have this response from the LLM, the rest is pretty much exactly what I did before, which is I need to parse the response, see which function has been called, and run that function. So what I'm going to show you now, with everything that you learned, is this process query function that really encapsulates all of these workflow or the process, such that when I say process query, what is the weather in New York, it doesn't give me that cryptic JSON output that you saw earlier, but rather a nice sentence, a human readable sentence that says the current weather in New York is sunny with a temperature of this, the wind is coming from the south and southwest, blah blah. Right? This is different from what the API gives you. The API gives you this cryptic thing, whereas here what I'm getting is much nicer. Well, the first part is what you already saw. You send a message to OpenAI along with the tools that are available and allow the LLM to decide if it needs to use the tool or not. You get the message out of the response, and then you check if it's called any tool or not. If it didn't, just return the content. For example, if you just said was 2 plus 2, there wouldn't be any tool called, and it would just return the response. That would be it. But if this condition is not met, then it look at the tool that was called. In our case, it was the weather tool. And then from that, it parses the name of the function and the arguments, just like the JSON that I showed you before. And it says, well, if the function is getWeather, and in our case it is because that's the only function or the tool we have, then it runs that function, get the results from it, and that would be the JSON with the temperature and the wind and all those things. And this is the new piece that we didn't have before. You call the LLM again with the response from the tool. Like, this was the original prompt, and this is the tool that I called, and this is the result from that tool call. Now give me a response. And you can see that here. This is the new message in the prompt that I'm adding. This one is from the tool as opposed to from the system or from the user. Now you have the message from the tool, and that has the response. Now, as you can tell, this is kind of not perfect, because what if in the second call to the OpenAI again made a call to another function? Then it wouldn't have the final answer. But given the simplicity of what we have here, the two calls to the OpenAI will definitely suffice. So that was the first technique, tools. The second technique I want to talk about to enhance LLM is called Retrieval Augmented Generation, or RAG. Let me give you two examples to illustrate the need or the problem that RAG tries to solve. Here are two examples. First, imagine your question is, what was the proposed budget for Philadelphia public transportation in 2010? LLM is not going to give you a good answer on that. It either doesn't know, or it will tell you something that you can't be confident about. It's based on the recollection of the internet, whatever it saw during the training process. The second example is quite similar. You want to know what comments a senator made about a particular topic on a given day. Again, it either doesn't know, or it's going to tell you something that you're not confident about. What you really want the LLM to do is to base its answer on a reference document. So, say in the first example, you want to be able to bring in the budget documents from the city hall along with your question, feed it to the LLM, and get a response that is based on that reference only. And the same thing about the second example. The challenge here is that these documents could be huge. Imagine you have a document that's 5 gigabytes. Definitely it's not going to fit into your context window. And even if it did, you end up with an extremely bloated prompt. And the LLM may not be powerful enough to parse through all of this huge document to figure out the exact answer that you need. RAG is designed to solve this kind of problems. So here's how RAG works. There is a pre-processing step, which is as follows. You take all the documents you have. You can go and grab all the documents from Philadelphia City Hall, or all the transcripts from the Senate or Congress or whatever, and feed it through this pipeline, which is quite simple. But what it does is it takes a document, it chunks it. Let's say each chunk could be almost 2 paragraphs long or 1,000 words long. You decide how big each chunk would be. And there's a process called vectorization, which I won't go into. Just say, imagine that you're indexing those chunks and then save them into a database. Now that you have that database of text chunks, you can build your RAG pipeline as follows. Say the user send a question, which was, what was the budget for Philadelphia public transportation? That question is routed to the prompt. What you see here at the bottom is a prompt template. It's just a small piece of code that concatenates or put together a prompt for you. And what you have on top is search. And what the search does is look at your question and find the relevant chunks of text in the database to pull from. You can configure your search to say, return the top 3 most relevant chunks of text related to this question. And by the way, that concept is called semantic search. You're searching not by keywords, but by the meaning. Now, when the search returns the result, you append the search results, which are the chunks of text related to the question, to the prompt. And now your new prompt, what comes out of this box, is going to be the question, some system messages, and the context. And that context are the chunks of text that you extracted from the database. And you instruct the LLM in your prompt to respond only based on the context provided in those chunks of text. And the problem here you solve are two things really. One is that you were able to base your response on a large body of document without worrying about the context window or squeezing everything into a prompt. That was one. And number two, when you get the response from LLM, you can point back to the exact place in the documentation or in the reference where the response was based off of. Now with that, now I'm going to give you a demo. So for the demo, I have this PDF file, which is about the Apollo program. It's a document off of NASA's website. I think it's about 500 pages, 430 pages long. And it's just the history of the Apollo program. Like, I could go down, there is a lot of text here, right? Now I want to build a RAG pipeline to answer questions based on this document only. All right, so let's build the RAG pipeline for this. If you remember, we have a pre-processing step where we want to chunk all these documents into small pieces of text, index it, store it in a database. And that's where I start doing it. While you could do a lot of these things from scratch, a popular open source library for dealing with language model is LangChain. And the idea is like you build a chain of steps or processes related to large language models, and hence the name LangChain. But I'm going to leverage this for that process. So I load my PDF documents. That's about 25 megabyte. And I split it. So each chunk is 1,000 characters long. And I have an overlap of chunks such that there is a continuity of the context. Otherwise, a chunk by itself may start from middle of a sentence and then lose visibility to what came before it. This is up to you. These are hyperparameters you can play around with. And then I split my document. So here are the chunks, and you see there is some pointers like which page it was, and you see the actual text. And there is an overlap. So if I say this piece, there must be two instances of it. This is one, and the other one must be here, the other one, right? So there's a bit of overlap, but here you got your chunks of text. And let me just point back to where we are in this process. So we are here, and now I'm gonna vectorize them and put them on the database. And for that, I'm using a vector database. Those details are not that important, but the vectorization happened here. Embedding and vectorization are the same thing here. And I'm defining my database. That's going to be on my own laptop. All right, now that I'm done with the pre-processing step, I can actually focus on the inference part. And so we are done with the top part. I'm going to do the part at the bottom. I'm specifying the language model, which is GPT-4o. Here's the prompt. This is the prompt template. So let's look at the prompt template together. It says use the following piece of context to answer the question at the end. If you don't know the answer, just say you don't know. Don't try to make up an answer. And the context is going to be the chunks of text that the search is going to identify as being the most relevant to the question. And then you have the question itself. And with that, I can create my chain. And again, the chain is going to have a few elements in it that you can see here. The question comes in, you want to do the search, you want to compile the prompt based on the context and all that, and then run it through the LLM and get the output. This is what we're accomplishing here. So here are the chunks, and you see there is some pointers like which page it was, and you see the actual text. And there is an overlap. So if I say this piece, there must be two instances of it. This is one, and the other one must be here, the other one, right? So there's a bit of overlap, but here you got your chunks of text. And let me just point back to where we are in this process. So we are here, and now I'm gonna vectorize them and put them on the database. And for that, I'm using a vector database. Those details are not that important, but the vectorization happened here. Embedding and vectorization are the same thing here. and I'm defining my database. That's going to be on my own laptop. All right, now that I'm done with the pre-processing step, I can actually focus on the inference part. And so if we're done with the top part, I'm going to do the part at the bottom. I'm specifying the language model, which is GPT-4o. Here's the prompt. This is the prompt template. So let's look at the prompt template together. It says use the following piece of context to answer the question at the end. If you don't know the answer, just say you don't know. Don't try to make up an answer. And the context is going to be the chunks of text that the search is going to identify as being the most relevant to the question. And then you have the question itself. And with that, I can create my chain. And again, the chain is going to have a few elements in it that you can see here. The question comes in, you want to do the search, you want to compile the prompt based on the context and all that, and then run it through the LLM and get the output. This is what we're accomplishing here. All right, with that, here's the question. What was the main outcome of the summer study at Woods Hole in 1965? Plug it into the chain and get the result. Now I have the debug mode on, so I'm going to see all the logs in between, but the final answer is this. Right, so this response is based on the document that I provided. And in particular, it used 3 chunks of text from that document to come up with the answer. Why 3? Because in my pipeline, I said I care about 3 top search results. And those 3 are concatenated into creating this context that you see here. And this is the entirety of that context. Right? And as a matter of fact, these 3 contexts are really pulled out of the documents. I should be able to find them, which I already did.